Well, thank you very much, Thibaut. I certainly appreciate coming here and speaking to you too. This time of year, I often talk quite a bit to growers really throughout the western U.S. and eastern U.S. as well about what we've just seen in the 2014 vintage and what is the current state of the climate, where does that take us? And so I'm going to be mostly talking about not any original research, but just kind of putting some things into perspective. And I'm going to try to go over these topics right here, talk about the state of the climate, look at global to regional variability and some of the issues that are out there, try to help you understand some of the things that I'm sure the media has caused some confusion in. Talk about the 2014 vintage into perspective. We've already talked about that a little bit, and I have some slides that are similar to what others had earlier. But then look at current conditions and carry that into the vintage 2015 and beyond, and kind of what does that mean, and get to a little bit of forecast. So what I want to do first is talk about the state of the climate where we are today. You've probably all recently seen the news that just came out. The 2014 year in terms of its climate was closed just this past week. And it ended up being the warmest year on record globally. But this map right here shows us some things. And I'm not going to try to point exactly to each one of these locations here, but there's a pattern across the mid-latitudes of the northern hemisphere that I want everybody to pay attention to, because what I'm going to describe to you in a little bit is related to what's driving that pattern. But if you look at this, we were in many places of the world quite warm in 2014, a few places a little cooler. We know that the trends are there, and I'll talk a little bit more about the trends here in just a minute. But there's some things to actually say about this. As I said, it's the warmest year since consistent records began in 1880. We also know that all 14 years in the 21st century rank as the top in the entire 135-year record. It's the 38th consecutive year since 1997 that the yearly global temperature has been above average. And this one is always kind of a startling one. If you were born after April 1985, you've never lived through a month that was colder than average. Okay, that's a pretty startling fact. If we go to this broader perspective, though, and we look at where we have consistent data at a global framework, we can clearly see we're in a place today where we're much warmer than we have been historically. If you listen to the media, there's a lot of things that have gone out there, especially in the climate change skeptic arena. There's been a lot been said about the warming slowing down, that 2013 and 14 weren't as warm as what people thought they might have been. However, when we look at observations and models that are out there, climate science and geophysics scientists today really know that much of what's been happening is that the ocean have been absorbing this, especially in the Pacific, that our ocean system is quite a large reservoir of heat, and it's been absorbing a lot of the global temperature increase. And we think that we may have reached a point at which the oceans are showing us a little bit of a response to that. Also, one of the interesting things that's been happening the past 5 years or so, the cold season, the winter seasons everywhere have not been warming to the same degree than they were maybe the 15 years before that. However, the warm season, spring, summer, and even into fall, has seen significant warming pretty much globally. A lot of ice loss, especially in the northern hemisphere, and quite a few extremes. And we'll talk more about extremes here in just a little bit. So combined, you take this all together, the warming process has slowed a little bit, but it's much warmer than anything we've experienced in the past. Now let's talk a little bit about variability, because this has kind of been the big kind of eye-opener for me. When I first started studying climate science, everybody was talking about trends in climate, and there was very little discussion about what climate change might mean to the variability of our climate system. And so for me, this has really been the big piece of what's been out there. So we need to talk a little bit about increased weather and climate variability. So first of all, this is just a map of the mid-latitudes in the northern hemisphere of our jet stream, and showing the highly scientific name wiggles through the mid-latitudes. These are actually called Rossby waves, and they're the nature of the flow of our atmosphere in the mid-latitudes right here is a result of the temperature gradient between the tropics and the pole. When you have a very large temperature gradient, these wiggles move very fast, and they have a tendency to have a lower amplitude. Okay? So we create a streaming structure. That's why it's called the jet stream. So this is where we've been historically, whenever we have a very large temperature gradient between the tropics and the North Pole. This is what we've seen for about the past 10 years. Slight different characteristics of it, but especially strong characteristics in the past 3 or 4 years. What happens here is that when the temperature gradient between the pole and the tropics starts to go down, the resulting jet streams respond to it. And they respond to it by slowing down and creating much greater north-south amplitudes. So they become a meandering river, more so than a set of wiggles in the pattern. This is called Arctic amplification, and it's the amplification in the north-south waves of these Rossby waves. We know that this has been happening. It's pretty evident in the data. It's pretty evident in watching jet stream patterns. And we've seen more season-to-season variation in this. We've seen it slowing down, creating these patterns that clearly show out. If you remember that map of global temperatures in 2014, warm in the west, cold in the east, warm over the Atlantic, cold in the next part of the Atlantic, warm in Europe, so on and so forth. It's all related to these wave structures that have been developed. We also know that this exists in the southern hemisphere as well, but the landmass difference across that mid-latitude sector creates a little bit different response to it, but it's similar kinds of things are happening there. So here's just some examples of it. These are just 2 maps from the United States in March of 2012 and March of 2013. So if you look at this, a pattern in 2012, exceptionally warm over most of the, especially mid to eastern part of the United States, relatively cold in the west. And then you go to 2013, and it's virtually the opposite. 2013, warmer west, colder east, and that's essentially where we are today. And that's where I think our short-term to mid-range kind of pattern is holding out again this spring. We also know that in the last 10 years alone, if you take the data and you add up all the statistics, we've seen more extremes in both precipitation and temperature than we have in the previous 40 years combined. And so something's going on, and we think it's because of this response of the climate system to this temperature gradient between the poles and the tropics. We also have a structure, and I know these maps are a little on the small side here, but let me explain it. If we take what's happening at the hemispheric level in the northern hemisphere and we bring it into the Pacific and North American sector, we have 2 large things that are occurring within the ocean system that really drive our climate. One is called the Pacific Decadal Oscillation. It's where the North Pacific, from the western United States going over toward Japan, sets up in a pattern of being warm versus cold waters. And then down in the tropics, we have the dreaded El Nino Southern Oscillation, the one that tends to produce the 49ers losing, stocks going down, all kinds of things. But anyway, the El Nino Southern Oscillation system is in the tropics, and it's also a sloshing back of the ocean temperatures across the ocean basin. There's only 4 different global structures shown here. There's actually a total of 9 different patterns that we can have. It can be either in a cold or warm phase, or it could be in a positive or negative phase, or they could all be neutral. And what happens within this structure is that it depends on the state of these 2 ocean areas. If the tropics are warm and the North Pacific is warm at the same time, it tends to amplify everything. If they're opposing phases, where the North Pacific may be cold and the tropics are warm, we get a different response. If things are at a neutral phase, then we typically don't see much. There's not much influence overall. So we have to realize that there's 9 total different structures here. And I'm only going to talk about 2 of the main ones. If we go to the situation in which we have a relatively warm coastal waters along California, Oregon, Washington, and then an El Nino going on in the tropics. The cold water, boy, and I can't see that at all. That woman that was up here earlier, I agree with you completely. Anyway, the cold water out over the North Pacific supports a trough to develop there. A trough is just simply a system in which we have a southerly extension of the jet stream across that region. Warmer water along the coast supports a ridge there. And together, Pacific Northwest tends to be warmer and drier. California tends to be a little bit wetter and slightly warmer. If we go to the opposite scenario, warm water over the central North Pacific supports a ridge structure. Again, an opposite structure in the jet stream pattern. And cool water along the west coast supports a trough there. Pacific Northwest has a tendency to be colder and wetter, and California tends to be drier and moderately colder. So we're in these two broad patterns. These are pretty easy to predict. The one that's on the right-hand side was 2010, 2011. Climate scientists could see those coming. I mean, it was pretty clear in the data that we were going to have cold vintages. There was just absolutely no doubt. And then 2013, 14 were pretty clear too, that we were going to have warm vintages. And you'll see in just a minute why those kind of forecasts or projections exist. So let's put the 2014 vintage into perspective. Thibaut's been talking about this. We've all had some different conversations around this. I'm just going to put it in a climate perspective. This is the climate division temperature ranks for the entire year for the United States. And you can clearly see a warm west and relatively cool east. This is for the entire year. But if you go to just the growing season, let's say March through September, the pattern looks exactly the same. If we go to maximum temperatures, the pattern's very similar. But if you go to minimum temperatures, the pattern is even more dramatic. Minimum temperatures were much more warmer than maximum temperatures were in 2014, especially across the western coast, all the way from Washington south into Southern California. Precipitation in 2014 really was not very remarkable. I mean, we had some variation across the country, a little wetter across the north, a little drier across parts of the south. But in reality, California was relatively close to normal, just slightly below normal in the southern part of California. But what happened is that this came on the heels of already 18 to 24 months of dry conditions previous. So it was an additive effect. If we look at growing season trends for California, again, this is California data for 1895 to 2014. We can see that the temperatures have been clearly going up over the entire annual period, plus over the growing season of March through September. It varies a little bit across California, though. These are the climate divisions in California. And if you look at the more northerly locations, they're somewhere between about 1.7 and 2 degree Fahrenheit trends over the past 100 years. While if you go down to the southern and more southeastern parts of California, you're looking at upwards of 3 degrees Fahrenheit changes over the past 100 years. So clearly trends are occurring. We can also look at this in terms of a distribution. Take a bell-shaped curve and put all those years into that curve. And what we know from this data is we know that since 1995, only 1999, 2010, and 2011 have been below the mean of the past 30-year climate normal period. If we put the 2 years in perspective that I always like to use here, 2010 and 2014, this is where they fit on the distribution. We were almost 2 standard deviations below average in 2010, and we're almost 3 standard deviations above average for 2014. And where this comes into play, of course, is potentially what the future might look like relative to these kinds of conditions. And we'll come back and talk about that in just a little bit. So let's look at current conditions. Where are we right now, and what does that mean for 2015? Sea surface temperatures is the most recent data that I could pull out for a global perspective. This is setting us up right now to having warm coastal waters from Baja all the way up into Alaska and a little bit cooler water out toward the center of the North Pacific. This is a classic condition for a warm spring and potentially warm growing season. Classic. And so by analog, by looking at the past and the history, that's what that would tell you. Okay? We do have a little bit of a lingering kind of El Nino condition in the tropics, but it's so weak that it probably doesn't matter very much, except for a little bit in the forecast. I'll show you that here in just a second. If you look at snow water equivalents, I think we just saw this, something similar to this by somebody else. But this is the pattern in the western U.S. for snow water equivalents in the mountains right now. It's kind of showing us typically what we're seeing in a really dry western U.S. and a little bit better conditions off into the Rockies toward the east. In 2013, this was even more dramatic in terms of their differences. After a fairly wet period that occurred earlier this winter, we have declining snowpacks west side that are really pretty dramatic. Precipitation amounts, I was talking to somebody just a moment ago, talking about how it looks like there's quite a bit of snow at certain elevations and above, but those lower elevation snow lines that are mostly kind of dependent upon mixes between precipitation and snow are really at record low levels all throughout Oregon, Washington, and California. So it really hasn't gotten any better. If you look at the drought monitor, that was shown earlier today as well. Of course, the drought monitor has been showing us a fairly dire conditions throughout much of the West. Going down into the locations here, we're actually in a little bit worse condition than we were last year at this time for certain categories of drought, but a little bit better in other categories. So, but we're still nowhere out of the woods yet in terms of drought intensity. So what's in store for 2015? This is a similar diagram, a little bit different than what was shown earlier, but a similar diagram. And one of the things that's showing here is that the light tan area, and even a little bit of green down into Arizona, is showing that the drought monitor system right now is pointing at there might be some recovery, but it's likely not going to be a lot. And most of that's probably going to happen from rainfall moving up into Arizona and New Mexico through the spring and into the monsoon season. If we look at NOAA forecast, the February, March, April 90-day forecast shows that greater chance of warm spring over the west. The probability holds as we move out into March, April, May, and beyond. So it looks like we're probably going to have a warm growing season overall. The February, March, April precipitation forecast points to a dry north. Equal chance in between, mean flip a coin and see what happens, and a greater chance for a slightly wet southern parts of California and over into Arizona. A lot of people think this is from the weak El Nino. It's just not strong enough to bring a lot of rainfall up further north. So what's in store for the future? I couldn't be remiss by talking, I think Thibaut wanted me to talk a little bit about climate change. Where are we? If we look at carbon emissions as being the big culprit of our planetary changes in climate, we haven't gotten anywhere better in the system in terms of managing carbon. 2013 and 14 are following the highest growth levels of carbon that are driving our climate models. We were hoping that some of the things that we might do from our climate perspective would better this, but it hasn't. If this is the case and it continues to play out and we're on that higher trajectory, then our temperature trajectory is probably going to go up as well. We're also going into a period where the solar activity is even higher. Sea surface temperatures have absorbed a lot of heat, and we think that they're going to start giving some of that off. And so we're in a place where all of these kind of puzzles come together and say we're likely to see more of what we've been seeing the past 2 years at least. If you look at distribution changes, this is 1895 to 2014 and how we've been for the past 100 plus years. If you look at 1981 to 2010, we've already been playing in a completely different temperature distribution for the past 30 years. If you go to a very conservative model for 2020 to 2040, that's where we're likely to be. Playing up at 2 standard deviations on average above what we've seen historically. If you go to the next 20-year period, that 2040 to 2060, we're going to be having average conditions that are like 2014 every year. Maybe that's not so bad, but it depends upon the nature of the relationship between temperature and precipitation patterns over time. So just in summary, we've had continued warming globally, although it's at a slightly slower rate than what we've historically have thought might occur. This is where I think there's a lot of very important information. Climate variability may be more of a concern with greater extremes across many different types of climate sectors. Hail, flood, droughts, heat stress events, and wider swings between seasonal conditions from region to region. Mid-latitude jet streams, both in the north and the south, are responding to Arctic warming, slowing and creating greater north-south amplitudes with an east-west pattern becoming stuck. And this is kind of what I think we've been seeing of late, that when those meanders get very large north-south, they have a tendency to become more kind of stuck in place over time. And that's when you hear people say, well, I'm worried that the ridge is coming back into place. Well, it's here right now, and it looks like it may be stuck for a few months. It could break down and allow some moisture in through different rain events, but it's likely to be stuck, I think, through the spring. There's a large disparity between temperature changes that are happening in different locations. Thibaut and I were talking about this. Places are not changing the same. Some places are warming at night and some places are warming at day. It means a completely different thing to your vines, whether you're having more activity happening at night or you're having heat stress events during the day. Soil temperatures are also following air temperatures. We just don't quite have enough data. And once we get enough data, I think we'll be looking at that more and more to show the relationships between soil temperatures and plant growth. And then a little forecast here. Let me just run through this. I think I've already said it, but tropical sea surface temperatures show neutral to mild El Nino, which typically doesn't mean much for us, fading into the summer period. North Pacific sea surface temperatures remain warmer than normal along the coast. This is driving greater ridging potential, a ridge over the west. Taken together, the conditions tilt the odds in favor of a warm and dry late winter, early spring for the west. Dry springs do tend to have, if you look at the data, dry springs do tend to have later individual cold events, frost events, and that's unfortunate. But during inversions and ridges, you can have clear skies at night. That can be problematic. There is the potential for some drought relief the further south you go. However, there's probably not going to be much recovery, just some relief. And dynamic models and historic analogs would point to our summer probably being a little closer to normal, even though I think it'll be warmer than normal still, but closer than maybe 2014 was. Now, if you don't trust me, you can always go here. And I just thought I'd give you what they're saying. This is the Farmer's Almanac for the North sector from Northern California up through Washington and Oregon and Southern California. Notice that they're really not calling for much in the way of precipitation. A little mixed temperature signals in terms of maybe a warmer spring and then a kind of an average to slightly cooler summer. But anyway, you can get a hold of that if you want. It's a good book for putting you to sleep at night. Anyway, thank you very much for your time. Appreciate it.